right, so sometimes the GMAT likes to ask about 3D shapes. Typically, these type of questions are considered hard. So even if you don't get them right, it's not the biggest deal in the world, but I want to make sure that we have a visualization of what each of these shapes look like and a little bit of information that could help in certain situations. So a cube is obviously this shape up here, and a cube is one in which all the sides, the height, the width, and the depth are all the same. So in a cube, if I know one of the sides is 4, that means the height is 4, the depth is 4, and everything else is 4 as well. Now the surface area of a cube, there are 6 sides, one on top, one on the side, one in the front, one on this side, and then the bottom, and then the back as well. So there are 6 sides to a cube, and each of those sides would have a surface area of 16 in this case. And so the surface area of the whole cube would be 6 for each side times 16, which would give us 96. Now, in this situation, the volume of the cube would be 4 cubed. So it's the length of a side cubed is the volume of a cube. And in that situation, we would have 64, which is 16 times 4. Now, a sphere and a hemisphere are related to each other. A hemisphere is just half of a sphere. It's a sphere where this bottom half was cut off. And if they ask you about a sphere's volume or anything like that, they're going to give you a formula for it, so I'm not going to cite that here. But the thing you should know about a sphere is in any direction, you get the radius. So no matter where you go from the center to the outside point, it's equal distant in every direction. And so the radius is what you get in every direction. And if you created a disk around this, across like the bottom or of the hemisphere or the center of the sphere, so a disk that went through directly through the center, the surface area of that disk and the surface area of the bottom of this hemisphere is just going to be pi r squared. So it's just the area of a circle with radius r. Now, a cone is a shape that looks like this, and basically you could make a cone with different types of bases, but a lot of times they like to test with a circular base. And they'll give you a formula for calculating area, but sometimes you could have a question, and I've seen this before, I actually saw this on my actual test, where you have a cone inscribed inside of a hemisphere. So you could imagine a cone whose base is the same as the base of this hemisphere, but whose top is touching the top center of the hemisphere and whose sides are angled like that. So imagine this cone inside of this sphere or hemisphere where the cone's base is the same as the base of that hemisphere. They're the same circle. So I've seen a question like that where they asked about the ratio of the volume of the cone to the volume of the hemisphere. It was like the hardest question on my test. I actually ended up guessing on it in the interest of time, and I still scored a 50 on quant. So you don't have to get every question right. You have to be educated about or intelligent about what types of questions you want to skip and just knowing when you want to move on. So that is a cone. A cylinder, we're expected to know the volume of. And the volume of a cylinder is the same as the volume of a circle, or the area of a circle on the base, times height. So the area of the circle here is pi r squared, and pi r squared times height will give us the volume of a cylinder. And that pretty much covers everything you need to know about 3D shapes except for one thing, which is the diagonal of a cube, which you see here in red. The diagonal of a cube, if the sides are all length s, the diagonal of a cube is s root 3, which is easy to remember because the diagonal of a square is s root 2. And a cube is just like a square except taken to a third degree. So s root 3 is the diagonal of a cube, and the reason is you can create a triangle across the bottom base here, and then a height here, and then the hypotenuse of this triangle would be this diagonal coming from the back to the front here. And in this triangle, this bottom line is s root 2, the top line, this side is s, so we have a right triangle where you have the height of s, you have s root 2, the diagonal of that bottom square, the bottom surface of the cube. And if you run Pythagorean theorem on this, run this through that formula, you'll get c squared, which is this being c, which is s squared times 2 plus s squared, which obviously equals 3s squared. And then the square root of that is root 3 times s, so s root 3. And that's why this follows that rule, but I just remember it because it's to the third degree, or like it's 3-dimensional, so it's s root 3, whereas a square is 2-dimensional and it's s root 2.